Senitu? If you're doing physics, you would have already realized that usually mechanics is a topic that comes under physics. So if you're wondering why we have mechanics under mathematics, why do you think that is? Because for those of you who do physics, you would find this module easy because you have already covered most of what you would be seeing in this under physics. Mechanics is actually, in mechanics, what we look at are places where mathematics is applied. It's what we call applied mathematics in the local syllabus. The main application of mathematics happens in physics when you learn how things work in nature. So in mechanics, you look at things like motion, to do with motion, how forces play a role when things are moving, and about energy, how energy gets transferred when you're moving, and things like that. It's all about it's all about things to do with motion and other things that are related to motion. So forces are related to motion, energy transfers are related to motion, and it's all about things that are happening when something is moving. So mechanics is the branch of, you can say, either mathematics or physics, where you look at things that are moving and the dynamics of it, and how mathematics is applied to understand how the motion is happening, and also to calculate certain things about moving objects. Okay. Right. So first, let me take you to I will show you how the lineup of topics happens in the syllabus, and then I will show you how we would be. Good morning, Afra. Oh, it's fine. Thank you for letting us know. And we know that usually you're not late, you're always on time. So that's fine. Okay, so here you all have this if you have the syllabus booklet. So in your syllabus, everything is summed up into 5 topics. And this is the order in which they give it. So you have forces in equilibrium, kinematics of motion in a straight line. So you can see it's all about motion, right? As I said, momentum, if you have not learned momentum before, momentum is also something to do with motion. Then Newton's laws of motion and energy, work, and power. So I would not want you to copy this because I'm sure you have the booklet like this. I mean, I didn't give you the hard copy of it, but I'm sure I sent the soft copy to you. So you all have this document. What I would want you to copy down is the lineup of topics in the sequence that we would be following. That would be in the same order that is given in the textbook, whichever the textbook that you might have. This is what I have, which is an earlier edition. I think you might be using a latest edition. Right, so your school will go in the order of the topics that are in the textbook. I will be following the same order. Okay, so I will show you that order. That is what I would want you to copy, and also I want to show this, right? So this is paper 4, right? Paper 4. There are 6 papers altogether. This is the paper 4. And it's the shorter paper. Out of the 4 components you do 2 long papers, 2 short papers. Mechanics and statistics are the short papers. So it's 1 hour, 15 minutes, and it carries only 50 marks. Whereas your P1 and P3 carry 75 marks. You know this already. So it's a short paper that has about 6 to 8 structured questions. And 40% of that will go towards AS, but you would be taking it at the end as A level. So 20% of this paper would go towards your final grade for your mathematics subject. Okay. Questions? Yes. Paper. So what I would want you to copy in your books today, the lineup of topics is what I have right here. This. Okay. So I actually have a little breakdown too. So we have, so as you saw in the syllabus, it's just 5 topics, but we have broken it down to 6 topics. The main 6 topics are uniform acceleration in a straight line, forces in equilibrium, forces and motion, and then non-uniform acceleration in a straight line, then energy, work and power, and finally momentum. So momentum, the topic momentum was introduced only last year. The batch just 1 year senior to you was the first batch who who faced this change for the first time. No, 2 batches. Okay, so you're the 3rd batch. So momentum is a new topic in this syllabus, quite new. And I have also shown a little breakdown, like subtopics under each of these. I would give you a few minutes to copy this down on the first page of your book under mechanics. So paper 4, I have mentioned that too here. You have the liberty of whether you might not want to copy the subtopics here, because we would anyway be going over that when we get to each of these topics. But if you think you want that, you can copy that too, or you can just write the 6 main topics. Okay, so what we're starting today is uniform acceleration in a straight line. And as you copy this down, I want you to be thinking about whether you have come across these topics before, how much of these you are already familiar with, and so on, okay? So because even if you are not doing physics in a 4 advanced level, in your O-level syllabus, for your O-level physics, you have done this. Why does it feel like a revision of us? Okay, so after you joined late, we talked about this. We talked about why it feels like physics, because it is physics. So you can view mechanics as physics or as an application of mathematics. Physics is applied mathematics. In physics, what you do is you study the nature of phenomenon that takes place in the nature, and to study that, what you use, the tools that you use are mathematics tools. So you can think of physics as a whole, just a branch of math where you are looking at applied math, where the pure mathematics that you learn is applied, okay? So this is like the intersection. Mechanics is an intersection between physics and math. It belongs to both math, the applied part of math, and it is physics. It is what physics is. So yeah, I was talking about it